called the Tangent-Secant Theorem. So let me draw now. According to Tangent-Secant Theorem, the square of the tangent drawn from an external point equals the product of the external segment of the secant line together with its entire length. Okay, so this means pt square is equal to pq external segment product is equals the product of external segment of the secant line together with its entire length. Entire length is what? This. So when we're writing it, we'll write it as pq plus qr. That's the way we write. Okay, fair enough. Now imagine we are given this length as say 13. This is 3 units. This one is x, and then we are having a point of contact from the center to the tangent, and then there is a hit over here. Okay, OT is a radius which is given as 5 units. We are asked to find the area of OTP. Now, how are we going to do this? Let me show you the solution. The circle has a tangent drawn from an external point by tangent radius theorem. The angle at T is equal to 90 degrees. Okay, so this angle is 90 degrees. So this would mean triangle OTP is right angled. Okay, now we have to find x also by Tangent-Secant Theorem. We know that, what do we know? X squared is equal to external segment 3 plus the entire segment. 3 of 3 plus 13, which means x squared is equal to 3 times of 16, which means x is equal to 4 times the root of 3. Okay, so x is equal to 4 times the root of 3. So since I mentioned that this is a right angle triangle, OT is 5 units. So this is 5 units, and we want the area of the triangle, right? Area is required. So area is equal to half times the base multiplied the height, right? And the sine 90 is 1, so no need to place sine 90. So 2 divides here 2 times, So 10 times the root of 3 square units. So this is the area of triangle OTP. Follow me. So that is the solution for this beautiful question.